Welcome to the show. Today we are going to be making a scrumptious dessert. Creme brulee. Creme brulee. Creme brulee. Creme brulee. Our recipe today calls for 580 mils of heavy cream, 125 grams of granulated sugar, 6 grams of kosher salt, 7.5 mils of vanilla extract, and 4 large egg yolks. Let's get started. First, we are going to warm the cream in a medium saucepan with 50 grams of sugar, vanilla, and salt. This smells very good. Very good. It smells like ice cream in here. Alright, our cream is almost done resting, so now we're going to prepare the egg mixture. We've already separated 4 egg yolks from their egg whites. We're going to mix this with the remaining 75 grams of sugar in a small mixing bowl. I'm straining the mixture to get any extra egg bits or just making sure we have a completely smooth mixture. Now I'm going to divide up this custard into the 4 ramekins I already set up. Now, while I was preparing the egg mixture, I set up a pot of boiling water on the stove. This is going to surround the ramekins and just almost act like a water bath while these are cooking in the oven. After we do that, they're going to cook in the oven about 38 minutes, and then we'll check them at that time. Creme brulee is done and it's perfect. We're going to let it cool in the water for 15 minutes and then out of the water for another 15. Then we're going to cover each ramekin in plastic wrap and let it cool in the fridge for 4 hours. Ta-da! Okay, so we took a step out of the kitchen to discuss the fun part, the chemistry. The 3 chemistry concepts we're going to be discussing include coagulation and proteins, the Maillard reaction, and caramelization. If you recall, when we added the cream to the egg yolks, we had to add a little at a time, ladling the hot cream into the mixture. This is because eggs are rich in proteins, and when proteins experience rapid temperature change, they go through 2 processes, denaturation and coagulation. In response to heat, the proteins unfold from their formerly tertiary and secondary structures into their primary structures. Tertiary proteins are bound by disulfide bonds, and their intermolecular forces include hydrogen bonding, dipole-dipole interactions, and London dispersion forces. Furthermore, they have hydrophobic interactions in which the nonpolar ribose group clusters on the inside of the protein, allowing the hydrophilic amino acids to interact with water molecules. In secondary protein structures, the molecules share hydrogen bonding, forming beta pleat and alpha helices structures. The high temperature introduces enough energy to overcome the intermolecular forces and covalent bonding in tertiary and secondary structures, but cannot break the peptide bonds in primary structures. After this process occurs, the amino acid strings coagulate. The oppositely charged ends of each strand attach to one another, forming protein clumps, which can visibly be observed as liquid transforming into a semi-solid or a solid. The next concept we are going to discuss is the Maillard reaction, or the Browning reaction. The Maillard reaction occurs between a reducing sugar and an amino group. When the 2 come in contact, the carbonyl group of the sugar molecule reacts with the amino group, and the synthesis reaction forms a glycosylamine and water. The glycosylamine compound undergoes amidori rearrangement and forms an isomer known as ketosamine. Under different alkaline and acidic conditions, the molecule behaves differently. In creme brulee, Maillard compounds are formed when the custard is baking. However, when the sugar is broiled on the surface of the custard, a different reaction is happening. This brings us to our third topic, caramelization. Unlike the Maillard reaction, caramelization only occurs between two sugars. When the sprinkled sugar is torched, the disaccharide sugar is broken into monosaccharide fructose and glucose. Caramelization occurs in at least 160 degrees Celsius. This temperature provides the energy specific to the disaccharide molecules to break the glycosidic linkage bond. The browning colors are produced by three different groups of polymers called carmelans, carmelins, and carmelins. When the equilibrium of the anomeric ring structures is established, the sucrose converts into fructose and glucose. Then a condensation reaction occurs, producing 4H2O-C24H36O18, known as carmelan. As heating continues, the intermolecular bonds form, creating the larger molecule AH2O-C36H50 and O25, known as carmelen. Then a dehydration and fragmentation reaction occurs, removing the water molecules and breaking the carmelen structure into C125H188O80, known as carmelin. During the intermediate steps of such isomerization reactions, polymer compounds form that are responsible for the flavor and aroma. In order of progression, diacetyl is responsible for the butterscotch flavor, esters and lactones for the sweet flavor, furans for that nutty flavor, maltol, you get that toasty or burnt, acetic acid, bitter, and so on until the sugar molecules are completely destroyed. All right, let's get back to the kitchen. Okay, so the creme brulees have been chilling in the fridge for 4 hours. And now we are going to use a blowtorch to form the glass-like sugar top. But first, I want to introduce our special surprise guest, Dr. Sammy Bell, to do the honors of lighting our torch. How are you, Dr. Bell?
Good. How are you?
I'm good, thank you. All right, so this is how it's going to work. I've already sprinkled granulated sugar on one of them.
Good.
So we have a good layer of the sugar crystals. Then you're going to hold the torch about 10 centimeters from the surface.
10 centimeters.
And while you flame, kind of rotate the ramekin until it's like a light brown to form that nice crust. Awesome.
10 centimeters.
All right, here we go. So the longer the flame is actually in contact with the sprinkled sugar, the darker the crust becomes. Like we discussed earlier, the color transformation is indicative of the caramelization reaction. If the crust becomes very dark, we can assume that the reaction proceeded to produce the more bitter compounds. We're going to flame until we get a nice caramel color and hopefully achieve the nutty sweet flavor of the esters, lactones, and furan compounds. The creme brulees have set for 2 minutes, and you can see there's a nice glassy top. So I am pleased to present our 2 taste testers.
Delicioso! Really good.
Thank you so much for joining us to make creme brulee. It was so fun, and I'm so glad you got to see how chemistry is involved in cooking. See you next time.